Now, as a momentum, this is the basic question. P is equal to mv. So there is a question or is to come in the examination whether momentum is a scalar or a vector quantity. So now they just simply ask you, just justify your answer. Now what we know, mass is a scalar and v, velocity is vector. So what we have seen is the mass into velocity. So mass into velocity is a product. So their product will be a vector. So this is velocity. Velocity. So their product will be a vector quantity. A vector quantity. So momentum is a vector quantity. After this, another units of force. In the SI system, 1 kg mass goes with 1 meter. It gives you the unit of 1 Newton. So 1 kilogram of mass when goes with 1 meter, so it is 1 meter square, gives you 1 Newton. This is similarly in CGS, 1 gram 1 centimeter square gives you 1 dyne. So in CGS system, in SI system, these are the two things we got it. Along with this, the traditional will get a unit of gravitational unit. Gravitational unit. The gravitational unit is nothing similar like this. This kilogram will be there. Automatically this kilogram will be there. And simply one single word, just 1 kg weight. It comes to 1 kg weight. So 1 kg weight as G, here A is not there, it comes with the G. So 1 kg weight will be what? 1 kg weight will be with multiplication of 9.8. So 1 kg F, 1 kg F. So this will be multiplication with the gravitational force in 9.8. These are the basic things. So this is the gravitational unit, this is the SI general unit. So along with this is the gram weight will get in the CGS, gram weight in the gravitational is MKS or the CGS. CGS, the 1 gram weight will be 1 gram F. So this, so it comes automatically like this way. So when 1 kg F is equal to 9.8, this similarly all are like this way. So this 1 Newton from this relationship, 1 Newton, what will get? 1 Newton will get what? The relationship between the Newton and the gram weight, this Newton and the gram weight, what will be the relation? The relation will be 1 Newton. So what 1 Newton will be? 10 to the power 5. 10 to the power 5. So 10 to the power 5 what? 10 to the power 5, as we previously know, dyne. So it will be dyne. So these are the basic things what we are just discussing on as a general unit, gravitational unit. So one after one will do like this way. After this we'll go into the vector compositions. So we'll just discuss on the vector, how a vector composites with the force, the derivations will be through vector analysis. So later on we'll do the vector by vector and we'll discuss through vector analysis the force. As we know, a vector, as a vector, what we have learned, this is x vector, this is y vector, this is z vector. This is, and along with this, we just define in the vector analysis compositions of vector. This is I cap, this is j cap, this is k cap. So when a force divides in three, so three component, the component of vectors, when the force divided in three components of vectors, so we can write this vector, the total F. So if F will be this F, we can write like this way, F. So what we can, so we can divide this F in x, y and z. So this F will be what? Fx. The first will be Fx with I cap, Fy y with j cap plus Fz with k cap. So this is vector compositions. We are just getting the force composites of vector compositions. So this will be what? After this we'll get the similarly the momentum also. If similarly P will be, what we'll get from P? P will be what? It goes same like this with P. The derivations will be same like with the P. Px I cap, Py j cap plus Pz k cap. So we are getting like this. We are getting like this way. Similarly, acceleration also. Ax I plus Ay j plus Az k. So the force here, the compositions, the composites of this momentum also, this is vector analysis. Through vector, we're just presenting the force in this format. So if the force divides on the x, y, z axis, so because vector give the analysis through x, y, z axis, so we'll get like this way. We can present the force in the vector format in this way. Now this vector format we can write in other way. So we can what the fx, as we know, we have written it in the previous way in the vector format. Now this fx we can write in the derivation also. So what will be the derivation also? D px with rate of change as usual. So it will be, because nothing except t time, you can't do anything with except. So what will get? A this max mass. So this will get mass with acceleration. Similarly, Fy, what will get? D P y dt m ay. Fz with dpz by dt is equal to maz. So these are the actually duplications of a force in the form of calculus, derivation in the form of vector. These are the way we can present. So you should learn all the aspects. So it will make you easier to fill the physics in second law in multiple way.